Welcome to AS System Software. When you use a computer, you interact with applications like browsers and games, but beneath that sits the system software, the invisible layer controlling the hardware. In this unit, we explore the software that keeps your machine alive. This is foundational for Paper 1. We start with the operating system. It is the essential bridge between the user and the raw hardware. You will learn its core functions, from providing a user interface to managing security, hardware, and errors. Without an operating system, your computer is just an expensive collection of metal and silicon. We will examine different types of operating systems, including batch processing and real-time systems, to see how they adapt to different environments. Once you understand the basics, we move to resource management, specifically how the system juggles memory and processes. A major job of the operating system is process management. A single core processor can only execute one instruction at a time. The operating system rapidly switches processes between ready, running, and waiting states, creating the seamless illusion of multitasking. We will trace this lifecycle and look at the process control block. Alongside this, you will dive into memory management, learning how the operating system uses techniques like paging, segmentation, and virtual memory to fit all these active processes into your main memory.
Next, we look at how the operating system handles storage, external hardware, and routine maintenance. You will explore file management, seeing how data is logically organized into directories and physically allocated on disks. You will learn why device drivers are mandatory software interfaces, acting as translators between the operating system and your hardware peripherals. Finally, we will cover utility software, exploring how disk defragmenters, backup tools, file compression, and antivirus programs maintain the long-term health and performance of your system. These utilities are vital for keeping the system running smoothly. The final major section of this unit tackles translators, bridging the gap between human-readable code and the processor. Your processor only understands pure binary machine code, so the high-level code you write in languages like Python or Java must be translated. You will compare compilers, which translate the entire program before execution, against interpreters, which translate and execute line by line. We will also dive into low-level languages, tracing exactly how assemblers convert assembly mnemonics into executable binary using one-to-one mapping and symbol tables. These translation mechanisms are heavily tested in the exam, and you will learn exactly how to justify the right translator for any given scenario. To sum up, this unit gives you the complete picture of how software controls hardware. By the end of these topics, you will be able to explain the critical functions of an operating system, trace how it manages memory and processes, understand file structures and device drivers, and confidently evaluate the translators that turn human-readable code into machine action. This knowledge is your key to unlocking the systems architecture section of the syllabus. You are ready to begin.